Hello and welcome back to my Java tutorial series to teach you how to program a physics simulator. Now if you don't recall, I'm just gonna start it back up from our results from the previous episode. As you can see, we established the list and you can add forces, and when you add a force it shows you this menu, unless it's net force, but it shows you this menu and you can like edit the force and you can edit the vector direction. And that's what we got done this last episode. Now this episode, we're actually going to start using java.auth, which is application Windows Toolkit, and we'll be actually drawing a free body diagram here to correspond with this. So every force will have a different vector that you'll be able to see on screen, and there'll be the actual free body. So we're going to start with that. Now we're going to do the very large majority of this in our render class, since, you know, guess what it's going to do? It's going to render. So we have right here where it is exactly going to be, right there. So the first thing we need to do is we're actually just going to do some convenience things. First thing we're going to do is do g.translate. And what happens since we're getting the graphics object from the frame, that means the center of the graphics object will be in the upper left corner of the window, which of course we can do, but it would be a bit more difficult than we want to. So we're going to translate it to where the center of our free body diagram is going to be, which is going to be at 500, 300. Okay. Now at the end here, what we're going to do, it's going to be at the end because all the lines are going to be having. We're going to want it to, the free body to cover up the lines, just so it looks better. So here we're going to do g.setColor, and our free body is just going to be color.gray. And then we're going to do g.fillOval. Since there's no fill circle, it's an oval, but a circle is a type of oval, so I'm perfectly fine with that. -50, since when you're drawing anything, you're drawing it from the upper left part of it, and since it's going to have a diameter of 100, which means it's going to have a radius of 50, so we have to account for that in the -50 starting area. So that's all we need at that end. Now we actually have to try to draw the lines. So first, we need to know what we're drawing, so we're going to create an array list, which I explained in the episode Better Than Arrays. I think that was episode 16, about that and iterators, and we're going to call it the force array, and it's going to of course be a new array list. And what we're going to be putting in here, oh wait, we need to import it, silly me. We're just gonna we're gonna see if we can stick with that, but of course we have to import on a new line, preferably java.util. I want to see if we can get away with just array list, because I kind of want to keep this to a minimal, just in case we import some stuff that we don't want. But either way, we'll get on with it. We'll do a for loop, integer I equals 0, and then we want I to be less than force array dot size, because it's like array dot length, but for force arrays it's size. And then of course a little unary operator to increase I every time. So we'll do force array dot add then force list, as I recall, to get the force map, which is the hash map of all of our forces, and we're just going to be getting stuff from that. Oh yeah, it's already there. Is that the class? Yeah. Force list.the list model. Oh wait, another thing we want to do is that we want to go on the force list and change the variable, this private default list model, and we're just going to make it public and static. It won't really harm anything, and it'll make things a lot easier for us. So again, we'll go back here, we do force list.list model, and we'll get the element at I, which is of course going to be a string. Okay. Oh yeah, we need another parenthesis. Okay. Now that we have all of our forces loaded in a more friendly format for us to draw them, we're just going to set our color now. And I think our vector should be, let's do black. That'll turn out interesting. Then another for loop. Size I plus plus. And now we're going to do some more complicated things. Newtons equals force array dot get I dot get force, because it's a force. Now newtons is obviously the magnitude of measurement for the force, and then we'll get rads, which stands for radians, equals to, also in this class, because I normally put this in my other classes, but 2 rad is the abbreviation for the class we're about to make, which stands for 2 radians, which will convert degrees to radians, which is exactly what we need. I'm just going to get the vector. Now, this is going to be public static, since it doesn't really depend on anything. And it's going to return a double. And it's going to accept a double as an argument. And we're going to return deg times math.pi divided by 180, because that's how in trigonometry and stuff you convert degrees to radians. Also, for a convenience method, we'll do the inverse of that, and we'll do 2 degrees. And of course, we'll return the inverse. We'll return rad times 180 divided by math.pi. There. So now we have those two, and now that works perfectly fine. So then we need just an inset, because since we're going to be drawing from the center of the oval, we want to, like, if our force is less than the radius of the oval, then you won't be able to see it. So what we're going to have is part of the line, the line is going to start on the edge of the circle, so we don't have to worry about the line being too small to see, unless of course it's a ridiculous amount. So we're going to round here, since when you're converting from like a float to an integer, it won't even round, it'll just automatically cut off the floating point value. So if you have like 59.999, it won't go to 60, it'll go to 59. So this will go easier, but since we want it to return an integer, we want it to also convert it to a float, because our answer will originally be a double. Because what round does, if you give it a double as an argument, it'll give you a long instead of an integer, which of course makes sense. But here we go, we'll do 50, which is the radius of our circle, times math dot cosine, whether you know basic trigonometry or not. And the reason we converted to radians is because how Java handles all their trigonometric functions is that they accept only radians and not degrees as parameters. So if we put it in degrees, we would get the completely wrong numbers, and that's why we had to convert it to radians. And then this time we'll do math.sine. Sine rads, in order to get the other inset that we need. And then of course now we're going to get the x position of the end of our line, which will be math dot round again, which of course ends with a float. And we'll do x inset plus the actual math we're getting to would be the newtons. The newtons multiplied by math dot cosine again, because the cosine of angle, if you're working in a circle, is the length of however much that angle extends out in the x direction. But yes, and of course we're going to do rads again for that, or radians. Basically the exact same thing for y. except that now we're doing sine instead of cosine, and we're using y inset. So y inset plus newtons times math dot sine. What's signum? Oh, significant function. Okay, I don't care. Curiosity, because the math class is always in the math class. Not like a math class, but the Java math class. Looks interesting. And now we actually get to the brunt of the business, which is a draw line, which you're going to draw from the origin of the circle. And since our graphics object is centered on the circle, we get to say just 0, 0. And then we'll say x and y, since we already set those as our final points, which is, of course, really nice. Now, this should be all we need. Of course, we can only check by actually running a test. Now, of course, if you have any errors, it'll prompt us in the console. So now, let's add app1, which stands for applied force 1. Now, let's make this say 50 newtons. Okay. So that is having a problem, in fact. Because as you can see, it's not displaying it at all. Now the problem with that, let's see, of course, troubleshooting is always the most fun thing to do when you're programming. But yeah, that's basically what programming is. You know, yeah. It's basically programming something, then spending the next hour and a half figuring out what the hell is wrong. What I know is wrong, now that I recall, is that when we ran it, whenever we change the value, even though this runs every tick, I don't think it updated the value, which I won't burden you with running that again. So I think in order to change this, we might have to go to the action listener. No. Okay, I think we go here. Now when we edit the button, when we press the edit button, this is the add listener. So an action performed. Oh wait, that's just for adding. We should go to force panel and go to their edit. Action performed. When the case is force, set force, you set the text. You also set the force. Which might not have updated the hash map, which we conveniently placed in here. Then, you know, like every single tick, this references it. Okay, well, real quick, something completely off topic, but we want to do a couple things in here. Doesn't make sense at all, completely off topic, but hey, we want to do some things in here. So first of all, we want to override 3 methods from object. The first one is going to be a public string to string. As you can see, as soon as we actually write something, we're just going to return this dot name. But you can see, you know, it overrides from object that class. So instead of giving us the name of the class plus an at, like if you hover over this, this is the normal value it would need. It would do get class.getName, so it would be force at a weird hexadecimal string of the random hash code of this object. But we just want it this way because we're cool like that. The next thing we're going to do is a public object clone. Now, so basically when we clone this, you know, that's exactly what it'll do. It'll clone it. So the thing we're going to add to this is return new force this dot name, this dot force, and of course this dot vector. So now we can clone it effectively and get an exact same force. The last thing we're going to do is going to be public boolean equals. Now this is just to check. Now we have to accept an object. So if object is an instance of, I taught you this about in conditionals, so if it is like a force that you're entering, then we're going to say force, object force equals, we're going to have to do some weird typecasting. So yeah, that's weird. So the first thing we do, we cast it to force. Since now we know it's a type of force, we can freely cast object to force, and then we clone it. But since clone returns object, we have to then cast that to force. Okay, then we can do the big stuff. So return, we're going to use a ternary operator here, since again I don't use those enough. Now we don't care about name when we're getting to equals, since you know I don't really care. Equals vector equals this dot vector question mark, return true, otherwise return false. And of course, if it isn't an instance of what the hell am I saying? I'm sorry. If it isn't an instance of force, we just want to turn false because we're like, hey, that's not even a force. Good luck. I'm just gonna save some space down there. So that's that part of it. Oh wait, 1 second. That was weird. In other news. That makes sense. Okay. Yeah. So we have that. Now we're back to the age-old. No, we're just back to what we were doing earlier regarding the why it wouldn't paint. So we set those bounds. Okay. Now, if we happen to go to force list, we're just checking all of our bases. This is basically, you know, this is what programming is. You program something is invariably wrong with it, and you go back and you check everything. Unfortunately, that's just always what happens. So get used to it. It's a life of frustration. So well, I'm making it sound a bit bad, but it's a life of well, you'll see. You'll see. So now, if we look at renderer, wait, I need to check something. Okay, well, true. Render. Okay, so this keeps running and it runs 20 times a second. That is true. So when you run render, you get the graphics from the frame. Indeed. It sounds very official when you say that. It really doesn't, but it's fun to say. Let's just try this one more time. We'll do gravity. We're going to set your force to 100 newtons. It obviously is not displaying anything. Now, we're going to go through basic bug fixing. First, I'm going to check, you know, this is newtons equals you're getting the force. You know, your force map, force list, the list model, the element at, whatever the hell that. Oh! Okay, I know what I did wrong. We're going to do I equals 1. No, I equals 0, but we're going to do I plus 1. Because we forgot that the element at 0 in the list is actually what we call net force, is the net force index. So if we did add another force, it would have worked out perfectly, but now it should also work out perfectly. It didn't. Just in case, I'm going to add another force, applied force number 2, we're going to set that to 50. We're going to set its vector to 45. Okay. So that obviously don't work. Even the screen refreshing doesn't even paint it. Okay, now we're going to do, it disposes it, sets the color down here, but sets the color up here first. So, you're adding, starting at the index of 0, which is, well, it depends to the end of the list. There's also a set method, but we don't want to do that because then we could get some null pointers. D equals 0, force array dot size. Force array does not have a size. That might be the problem, indeed. Actually, it might not be. Okay, yes, it is indeed the problem. Because force array does not have a size. Again, it's like looking for a needle in a haystack sometimes. What we actually wanted to do is list model dot size. If it doesn't work now, then it'll work. Trust me. You know. Have I ever steered you wrong? Let's look at this. Born physics renderer. Now we're having a problem here because they really don't like us. They despise us right now. I mean, what? So we're getting list.size. That's I plus 1, which it should be, because I starts at 0. List model.size when we do it is 2. Well, no, yeah, it's 2. So I equals 0. Right here it goes through 0. 0 plus 1 is 1. So that means it's getting our applied app 1 thing. Yeah. Then it runs through again. It goes to 1. So that means, in order to make it work, yeah, this is simple. And we'll just set that to 1 and not even worry about that, because the problem is it was running through an extra time, and that didn't work. Okay. Applied 1. Okay, it's working now. Don't ask me how I know. But if we do it, it's 50 now. That is 50 pixels long, which is just easy. So if we set this to 45, obviously it's handling negatives incorrectly. And now this is, well, it's handing Y negatives incorrectly. And also it's not erasing this, which is easy enough to fix, which I will show you really soon. I'm terribly sorry if this episode's going wrong. The problem with that, we need to set this to negative, so it actually goes upwards to begin with. And then to make it work, we're going to go to force panel. And whenever this happens, we're gonna kill like 3 birds with 1 stone here. You know, when you have a J option pane, there's some other things that could happen. One, what you input to the field could be not a number. You could actually input a string. So if we try to parse the float, it'll give us an error. And also, if you exit out and say cancel, then it'll give a null pointer exception for when we reference new force. So now we're going to encase this all in a try block. We know by it not telling us that we don't have to do a try block, but again, it's a programmer's responsibility when he knows that errors are possible that he is to use this. So the first thing we're going to try to catch, I should say, is the number something exception. Give me a couple seconds as I recall. Give me a couple seconds while I recall. It's a number format exception. So we're going to catch a number format exception, NFE for number format exception. What we're going to do here is we're actually going to make a new J option pane. And we're going to say show message dialog. And I just like getting the ones with like the most amount of choices. Its parent component will be main.frame, so you can't edit anything. The message will be input was an invalid number. The title of the window would be invalid input. Message icon will be JOptionPane dot warning. Wait, no, that's the. Did it say icon? I don't think. Oh wait, was that? Was that message type? Yeah, that was message type. Okay, that's perfect. And then right here, it'll be null. And that's only if we catch the number format exception. The other thing is catch, if I can spell it right, which you know I rarely can, a null pointer exception. This is when you press, like, cancel instead of the other thing. Basically, we don't care. We'll just leave that there. And then in the finally, which I don't use that often, to be fair, we're just going to do refresh the screen panel. So main.screenPanel.setVisible false, because in order to redraw it, you have to make it not visible, which is I think one of a few, very few setbacks of swing. So then we're gonna revalidate, and then of course after revalidate, why don't we just repaint, and then after all is said and done, we can make it visible. Ta-da! Indeed. So now it all should be good. So now I'm just going to show an example. Now we're going to do applied force 1. We're going to set it to, this is totally a floating point integer. Input was invalid number. Okay, I misspelled that. I'll fix that real quick when we're done. If we set it to, if we just press cancel, we wouldn't get an error. You might not know this, but earlier we would have gotten an error. 50. We can now set it to 45 degrees. Or we can't. What if we set it to 90? It'll disappear. 180. Oh, that worked. Oh, I see what it's doing. Okay, I know exactly what it's doing. It's appropriating the X value correctly, but it's appropriating the Y value incorrectly. So that's also an easy fix. Oh, while I'm here, while I remember, input was invalid number. Render, it should be Y inset newtons times sine of radians. I mean, what else would it be? Okay, the inset has to be negative as well. My apologies. If our newtons were a lot higher than that, that would have been apparent. So whenever there's a problem, I'll start doing that. So not only can we set this to say 75 newtons and put it at an angle of 45 degrees, which look, it's working properly. We are all miracle workers here. We can also make another one, set it to 50, set it to angle 2, I don't know, let's just go 225, which is also happens to be completely opposite. Then let's just go crazy here, add gravity. It should have a vector of 270 degrees, and let's say this mofo is extremely heavy at like 150 newtons. That's a pretty long vector. And you can do this all day, you know. I mean, especially, let's see, you know, someone stops pulling on it that way. We'll remove it. Look, it disappears. We're awesome. Our physics simulator is going good. We have that going. We have the free body diagram working. Now, I have no idea how long this episode is. I'm sorry if it's longer than I wanted it to be. I'll wrap it up pretty quickly. Next time we'll be working on it calculating the resultant vector. Like, if you have two forces acting on a body, one going that way and one going that way, obviously its end direction will be somewhere this way. Well, kind of short, though. But we'll do that next episode, so I'll see you next time. I'm Boralaborn, and I wish you good programming.